Okay guys, now let's look at question 37. Now question 37 is about extracting of aluminium from aluminium oxide trihydride ore. Okay, so this whole process involves multiple steps. So this is basically a multiple step process, and you have specific ways to solve stoichiometric questions that involves multiple steps. So let's look at the steps one by one. Okay, you have step 1, you have step 2, you have step 3, and finally you have step 4, which is the electrolysis. Now, the first question is asking for the maximum mass of aluminium that can be yielded, assuming 100 tons of bauxite that contains 30.2 by mass aluminium oxide trihydride is used. Now, remember when they say ore, meaning the mineral is impure. Okay, there might be other mineral or other substances apart from this aluminium oxide trihydride. Okay, so what you need to do is, first of all, identify what is the mass of aluminium oxide trihydrate. You cannot immediately use this 100 tons because this 100 ton is impure. Okay, so you have to use this information to find out the mass of aluminium oxide trihydrate. Only then you commence your calculations. Okay, so first step, find the mass. Find the mass of aluminium Okay, so since it's 30.2% out of that 100 tons, okay, so basically it's 100 tons times 30.2 over 100. So you get 30.2 tons. Now make sure you convert this to grams, because your next subsequent calculation would involve calculation of number of moles and so on. So that one you'll have to use mass in gram. So 30.2 ton is basically 30.2 times 10 to the power of 6 grams. Okay, next you'll have to find the number of mole, because you want to find how many moles of aluminium oxide trihydrate was used. Only then you can identify how many moles of aluminium was produced based on the equation. So the number of mole of aluminium oxide trihydrate would be, take the mass, 30.2 times 10 to the power of negative 6, divide by the molar mass of this, which is 156.608. Okay, and you will have 193,580 moles. Now, this is where the question becomes tricky. How many moles of aluminium will be produced with this number of mole of aluminium oxide trihydrate? This is where you have to go backwards, go up to the question again, and identify how many moles you would produce. Okay, now, a lot of students, what they did was, they identified the aluminium oxide trihydrate here, and then they straight away went to the aluminium and they thought, 1 mole of aluminium oxide trihydrate will produce 4 moles of aluminium, which is definitely wrong. Okay, you'll have to go step by step. So I'm going to assume I have 1 mole of aluminium oxide trihydrate. So let's say I have 1 mole of this. According to this equation, 1 mole of aluminium oxide trihydrate produces 2 moles of sodium aluminium oxide. Okay, so I'm going to use 2 moles here. Okay, and I'm going to bring, since I got 2 moles, I'm going to bring this forward to my second step. Okay, so far it's easy because the number of moles I have and the number of mole here in the stoichiometric ratio is the same. So I just have to follow. So 2 moles of this produces 1 mole of this. So I also have 2 moles, so I will also produce 1 mole of this. And again, I'm going to bring this forward to my third step. Okay, and 1 mole of aluminium oxide trihydrate produces 1 mole of aluminium oxide. Okay, this is where it becomes different. Now what I have, okay, you have to assume the blue numbers, the one that I just wrote, is what I have. Assuming this is what I have as I go through the steps. The number of moles in the equation is the stoichiometric ratio. Okay, now since I have only 1 mole, my 1 mole of aluminium oxide in real life, in practical life, will not miraculously become 2 moles, correct? So I'm going to bring forward my 1 mole to my last step. Okay, but I can use this stoichiometric ratio to identify how many moles of aluminium I will produce. So according to the stoichiometric ratio, 2 moles of aluminium oxide produces 4 moles of aluminium. That is if I have 2 moles. So what if I have 1 mole? If I have 1 mole, I will produce 2 moles. So actually, if I started off this whole process with 1 mole of aluminium oxide trihydrate, I'm going to end up with 2 moles of aluminium and not 4. Okay, so now since you have identified that, that is if I have 1 mole. So what if I have this number of moles? All I have to do is just multiply this by 2. Okay, so the number of mole of aluminium would be 2 times the number of mole of aluminium oxide trihydrate. So 2 times 193,580, I will have. And finally, since they're asking for mass, all you have to do now is take the number of moles and multiply by the molar mass of aluminium. You will get, which is 10.4 times 10 to the power of 6 grams, or 10.4 tons. Okay. Next question. Okay, the next question is actually quite straightforward. If you look at the step, they're just asking you to calculate the volume of 8 molar concentrated sodium hydroxide solution that will be required to dissolve all the aluminium oxide trihydrate in step 1. And if you look at step 1, you would need 2 moles of sodium hydroxide for every 1 mole of aluminium oxide trihydrate. Okay, so you have already identified the number of moles of aluminium oxide trihydrate, which is this one. Okay, so the number of mole of sodium hydroxide you would need would be 2 times again. Okay, so you would get number of moles similar to the number of mole of aluminium actually. Oops, what happened? Okay, 387160. Moles. Okay, now how do you find the volume? You can just use N equals to CV. So you're going to calculate your V. So V would be equals to N over C. You have your N, you just calculated your N, and your C is in the question. So V is equals to N over C, which is 387160 over 8. Okay, which is 48395 liters, or 4.84 times 10 to the power of 4 liters. And you're done. Next, okay, electrolysis equations. Okay, how do you identify? Now, first things first, step 4. They're talking about step 4. So you just have to go back to the question, and you can see in step 4, aluminium oxide produces aluminium, carbon produces CO2. That's basically your reactants and products. Now, how are you going to come up with the equation? Now remember, it is molten, so you cannot use Al2O3, okay, because they've already separated into ions. Okay, so your reduction would be Al3 plus 3 electrons, you will get aluminium. Okay, I think this one was quite straightforward. Okay, you either get it right or you might have accidentally used Al2O3 becoming aluminium. Okay, but this is where majority of the students got it wrong. So now you know that carbon produces CO2. Majority of the students tried to balance the equation using the usual balancing process, which is, oh, I have 2 oxygen here, I would have to add 2 water molecules on this side, and then I'll have to balance my H on the other side. But the problem is this is not an aqueous solution electrolyte. There is no water present. It is a molten substance. Okay, now how are you going to end up with your O2? Now remember, this thing here came from Al2O3. Now this Al2O3 is molten into Al3 plus, okay, and oxides. So can you add oxides here? Yes, you can. Okay, and all you have to do now is to balance the equation. You have 4 negative charges, so you have to add 4 electrons here. And to balance the equation, you'll have to multiply this by 4. You have to multiply this by 3, and you'll end up with okay, done. Next question. Okay, state the change in oxidation number of carbon in step 4. Now, how do you do that? You started off with carbon, and then you ended up with CO2. Now, remember, every element on its own, okay, will be 0. So it started off with 0, and what then happened? What is the oxidation number for C in carbon dioxide? Now you know oxygen is -2. Okay, and you have 2 oxygen here, so it's -4. So in order for this molecule to be neutral without charge, the carbon has to be +4. So 0 to +4. Okay, let's look at what happens next. Okay, list 2 observations that could be found at the positive carbon electrode. Okay, now I know most of the time you memorize positive as cathode, but remember this is electrolysis, so positive here means anode. Okay, and what happened at anode? Let's look at the equation. Anode is where oxidation occurs. So your carbon became carbon dioxide. So what's going to happen to your carbon electrode? Your carbon electrode is going to become thinner. Okay, so carbon electrode becomes thinner, and what do you produce? You produce CO2, so colorless, odorless, effervescence is produced. Now, this is compulsory. Colorless, odorless. CO2 gas is a colorless, odorless gas. Colorless, odorless has to be included. Okay. Question F. State 2 reasons for using high temperature. Now, obviously, you have learned equilibrium, you have learned reaction rates. You know high temperature will definitely increase your reaction rate. So you can say 1, maintain high rate of reaction. Okay, and secondly, remember this is a molten electrolyte, so obviously an ionic compound would need very, very high temperature to remain molten. So oxide maintains in molten state. Okay, and finally, now I think there's no problem. A lot of you may manage to identify that CO2 gas is released. So when you talk about emission of CO2, you basically have to directly relate that to the impact. Okay, so basically you have to talk about, oh, what happens when you produce aluminium. So while producing aluminium, I produce CO2 gas, and what happens to the environment due to this emission of CO2 gas? You can say the usual things that you have already learned. You can say ocean acidification. You can say enhanced greenhouse effect. Okay, or you can also write anything else that was written in the marking key. Okay, but this was the usual answer, which is correct. Okay, but please don't say CO2 produces acid rain. No, it does not. Okay, and that's it. Question 37.